Question 4a. Use mathematical induction to prove that for all integers n greater than or equal to 3, that 1 minus 2 over 3 times 1 minus 2 over 4 times 1 minus 2 over 5 times ... times 1 minus 2 over n equals 2 over n times n minus 1. The first step is to show the statement is true for some value of n. And in this case, the smallest value of n that we can test is n equals 3. Substituting n equals 3 into the statement, we have left-hand side equals 1 minus 2 over 3, which equals 1 over 3, and the right-hand side equals 2 over 3 times 3 minus 1, which equals 1 over 3. Now the left-hand side equals the right-hand side, hence the statement is true for n equals 3. Next, we assume the statement is true for n equals k for integer values of k greater than or equal to 3. That is, 1 minus 2 over 3 times 1 minus 2 over 4 times 1 minus 2 over 5 times ... times 1 minus 2 over k equals 2 over k times k minus 1. Next, we show the statement is true for n equals k plus 1. So from the left-hand side of the assumption, we have 1 minus 2 over 3 times 1 minus 2 over 4 times 1 minus 2 over 5 times ... times 1 minus 2 over k times the next term along, which is 1 minus 2 over k plus 1. Now from the assumption, we can replace these terms, excluding the 1 minus 2 over k plus 1, with the right-hand side of the assumption, which is 2 over k times k minus 1. So that equals 2 over k times k minus 1 multiplied by 1 minus 2 over k plus 1. Expanding the brackets, that equals 2 over k times k minus 1 minus 4 over k times k minus 1 times k plus 1. And that equals 2 times k plus 1 over k times k minus 1 times k plus 1 minus 4 over k times k minus 1 times k plus 1. So notice now we have common denominators with both fractions, so we can add the numerators together. So that equals 2k plus 2 minus 4 over k times k minus 1 times k plus 1. And simplifying the numerator, that equals 2k minus 2 over k times k minus 1 times k plus 1. And factorising out 2, that equals 2 times k minus 1 over k times k minus 1 times k plus 1. And we can cancel the k minus 1 in the numerator with the k minus 1 in the denominator. And that equals 2 over k times k plus 1. But n equals k plus 1, hence k equals n minus 1. So we can rewrite this expression here in terms of n. So that equals 2 over n times n minus 1, which equals the right-hand side of the original statement. Therefore, by the principle of mathematical induction, the statement is true for all integers n greater than or equal to 3.